It's very important to the process of understanding Google Cloud and passing the certification exam that you go through the question and attempt answering it yourself first. So pause the video, work through the question. We'll catch up in just a little while and I'll show you how I do it. In this project scenario, to reduce costs, the Director of Engineering has required all developers to move their development infrastructure resources from on-premises to virtual machines on Google Cloud. These resources go through the multiple start-stop events during the day and require state to persist. You have been asked to design the process of running a development environment in Google Cloud while providing cost visibility to the finance department. Which 2 steps should you take? So quite a few options here. We will study the requirements quickly and then consider each of the options. So the first thing is that this team is moving the development infrastructure from on-prem VMs to Google Cloud. Right? So we have to closely mimic the experience that developers have when on-prem while also being on Google Cloud. Right? We can't have extremely different choices. We also know that these resources are going to go through multiple start-stop events, and between them, right, between a restart, what existed before in terms of data should be available again after the machines are rebooted. Right? So there has to be persistent, durable data. We also have to provide cost visibility to the finance team. So we have to include some features that allow us to track the ongoing operational costs. When you're working on a machine on-prem, you've already invested with a higher fixed price cost by acquiring these machines, and you don't really care how often it is used. But on the cloud, we have an opportunity to just pay for what we use. So if we shut down the systems, if you're not using it, we could save a lot of cost. Yeah. So we want to provide that information to the finance team so that they can analyze it. Now let's go through each of the options. Option A suggests use persistent disk to store the state, then start and stop the VM as needed. So what does persistent disks provide? They provide durability, right? Once you save something onto a disk, you are guaranteed that you will be able to retrieve it. Of course, unless the disk is spoiled or you delete it, but that's a different story. Essentially, these disks provide durability, right? So if a VM is running and a running program saves some data, and even after the VM is shut down, if you reattach the disk, you're going to get back that original data. And this is exactly what we want, right? Because code that was written the previous day should not disappear just because you reboot your machine. So option A sounds real good and suitable for our requirement, and therefore we will retain that as a good contender for the final list. Option B suggests use the auto delete flag on all persistent disks before stopping the VM. This will delete the disk when the VM is shut down. Right? That's the exact opposite of what we want in the requirement. We want the data to be retained. It should not be that when the VM is shut down, the disk is automatically removed and deleted. So option B is definitely not a choice, and we will eliminate that. Option C suggests we apply VM CPU utilization label and include it in the BigQuery billing export. Now, CPU utilization is not a good metric for understanding VM use in development. Right? Chances are that maybe the developer is looking up documentation, or is in a meeting, or is maybe writing email, during which the CPU is not highly utilized. If that is assumed to be an indication that the VM is not required, that would be the wrong conclusion to make. Right? So CPU utilization is not a suitable metric to decide the usage pattern of the VMs in development. Applying labels to resources, though, such that it can be later analyzed in BigQuery, is a good thing to do. It is possible to assign labels to, say, the VMs being used by various teams. Say, for example, there is a web team right? The front end team. And then let's say there are two back end teams, one coding in Golang, another one coding in Java. You can assign labels to these various developer machines such that you can group them together later and see whether one of them is incurring too high a cost compared to, say, some other team, or any one particular developer machine is using or incurring a cost that is much higher than the others, and then try to find out why that is so. So having labels for these VMs such that it can be exported to BigQuery and analyzed is a good thing. However, in this option, it is saying that it is going to be connected, right? The labels are going to be connected to the metric of CPU utilization, which is not good. So in combination, this is not a good option, and therefore we will eliminate option C. Option D suggests that we use BigQuery billing export and labels to relate cost to groups. So, like I said, labels are a good way to group similar resources at scale. When you've got a development team of, say, 100 or 1,000 people, you can say all the people who are using the or doing web end or front end development for the web be assigned some label for the VMs. Whereas maybe somebody who's using or doing work in AI and you have to run long jobs overnight as part of the training process will use a separate label. And you can see that the cost for the group that is using or who's doing AI training and all that, machine learning training, will obviously have, say, greater cost because they probably have to run their training process through the night. Whereas somebody who's working, say, on front-end development for the web does not necessarily have to keep their machine running overnight. Right? So these labels allow you to group similar resources irrespective of the scale at which you're dealing with. Right? Later in BigQuery, you will be able to see that for this label, say for the web label, hey, here was a cost. For the machine learning team, hey, here was a cost, right? Machine learning team individual one, here is a cost. And this allows you to analyze that data across everybody in your company. So using BigQuery billing export and labels and then to relate that to multiple groups is a good approach in being able to give that visibility of cost and usage to the finance department. So this is a great option again, and we are going to choose this as a good contender, but still continue looking at the other options. Option E suggests store all state in local SSD, then snapshot the persistent disk and terminate the VM. Local SSDs are ephemeral. They do not survive a VM restart. So if you save something to disk and the machine accidentally restarts that you didn't intend it to, then you're going to lose all that data. If even you control that you took a snapshot of the persistent disk, saved it somewhere, and then the next time you restarted the VM, you connected that snapshot, you brought it back from that snapshot, it just increases the amount of overhead that you have to deal with, right? There's just more administrative tasks. And that is not required in this particular case because we've already seen an option that is better than that. So using local SSD is not a good option because it's ephemeral. And even if you're able to occasionally save it out in some way, right? You save out the data to some other person's disk and then you snapshot it, it just becomes too roundabout. So we will eliminate option E. Option F suggests that we store all state in cloud storage, then snapshot the persistent disk and terminate the VM. Now, cloud storage is object storage, okay, and it's not block storage like hard disks. Though we kind of use them similarly as if we are working with files, their underlying working is different, right? And some of the things just don't transfer very well between these two options for storage. So cloud storage is not the app storage when migrating a dev environment to Google Cloud. Again, we saw about snapshotting persistent disk, though possible, it's just too roundabout and it increases the administrative overhead and therefore it does not work for us. Hence, we will eliminate option F also. Looking at all of them now, only two options stand out as suitable for what we want to get done. which is A, to use persistent disk to store the state, after which you can start and stop the VM as you need. Also, label the resources depending on the group or the dev team that is a part of, and then export that data to BigQuery so that it can be analyzed by the finance team. If you're interested in picking up loads more learning on Google Cloud, go ahead and subscribe right away.